Here we have an example of groundwater coming through Tramner Bar. Now Tramner is probably unique amongst the gravel bars insofar as there's just these large swaths of groundwater appearing to come through it. Other bars also have groundwater. It's not specific to Tramner, but Tramner does have, it appears to have higher densities of stream-rearing sockeye than any of the other bars. So it's kind of a special bar, which would be disappointing if it were affected by human activities. But you can see here the groundwater is, or hyporheic water is coming out of the gravel. It's bubbling up, and the velocity is such that it's moving the sand grains. And this is a real pea soup of biological activity. You can see the enormous numbers of pink salmon carcasses. So these bones, they decompose. We have nitrogen and phosphorus. These two elements are marine-derived nitrogen, marine-derived phosphorus, and provides a really important base for fertilizing the lower trophic levels, the bacterial levels and the algal levels. So this you can see all of the dead salmon that have ended up here. The bones are decaying, and this freshwater ecosystem is just a real potpourri of biological activity and fish activity.
So when they do gravel extractions in an area like this can really destroy and upset the balance of nature, so to speak, I guess?
Well, you know, you don't see these groundwater lenses just everywhere, and the proposed extraction would be upstream of the groundwater areas. And the concern, of course, is that the extraction somehow interferes with how the groundwater moves through the gravel and then pops up on the other side of the bar. So any change in the morphological character, the shape of the bar, is something that I would say is of concern to anybody and everybody that wants to see a stable and sustainable ecosystem here on the Fraser River and the gravel reach. But yeah, you know, and a lot of it, I would say, is not really predictable. And the other thing too is that the gravel removal hasn't been properly inventoried and assessed in terms of its impact. And there's a lot of people that are trying, but it's a difficult process to come to grips with it. It's a tough subject. It's a very complicated subject. So we're in some regards we're whistling in the wind, but we do know that these are pretty spectacular areas, and this is, as you can see right here, from all the the hundreds and maybe thousands of dead salmon, the carcasses, the backbones. This is something. This is an area that's pretty special. We're
standing in the area of the dead, but there's living underneath, right?
It's the big circle of life. Yeah, the salmon decay, the pink carcasses turn to mush. The seagulls eat the dead fish. Sturgeon eat the fish as they're swimming or cascading through the bottom as they drift away. But then, as there's just too many carcasses for the bird life or the larger scavengers to eat the carcasses, and so as the carcasses in essence melt, those dead bodies become life again because the lower trophic levels, the periphyte and the bacteria, really are stimulated by those nutrients.
Good. Well, I see they're going to do some seining down here.
Maybe we can take a look at a red here. I'd really like
to
show you the
sure.
reds here. This is something pretty. Jason and I saw it. I hope I can find one. But the red is just you see a red underwater, so it doesn't look like anything.
Mm-hmm.
But there are some big reds here that were.
Once again, these are pink reds. Just touch again on the people that could be watching this video, the importance of that groundwater, as we walk along here looking for that red.
Okay. Well, the groundwater, again, you can see there's little potholes here, and those potholes are all where fish have spawned, so those are reds.
Mm-hmm.
And so as the main channel water surface elevation drops,
I see. Mm-hmm.
The groundwater can often act as a kind of a saving grace, because there isn't water coming over the top of the bar, but the embryos and alevins in the gravel are still irrigated by groundwater that's percolating through. Those little guys might survive, And so that's what groundwater in some locations is really important. And again, you know, we'd be worried that that the large-scale gravel removal that's proposed to the top of the bar might disrupt this really wonderful kind of a situation. You can see all those little potholes. Well, those are all areas where salmon have dug.
It's not just the effect of where they take the gravel out that is the destructive aspect of it. It's what happens further down below the extraction areas.
Well, you see, if they take a large amount of gravel out, the bar will delink in terms of its structure. So it will basically, the stability of it will be destroyed. So the gravel is going to move around, it's going to try and fill up. There's going to be head cutting, so that is erosion upstream, down cutting, erosion downstream, and then lateral cutting. So the whole structure of the bar is going to fall apart. So the groundwater here almost certainly is a function of, you know, the way the bar is formed. And if you take a huge swath of material in the upstream areas, well, you know, you're somehow probably intercepting the discharge of that groundwater into these lower parts, this really beautiful habitat. The other thing too is that you know, when you take the large amount of gravel out, the whole bar, you know, for a number of years or decades even, starts to fall apart. And this is a pretty stable bar. If you look on the aerial photographs that UBC Geography has put together, this bar I think is like a half a century old. It's not a new bar. It's slowly growing, and it's growing to the south. The islands along Hurling Channel are being eroded away by the main channel, but this bar is slowly growing in a southward direction, and it's a pretty special kind of a bar.
Where were those reds that you were hoping to see?
We'll come and look at them.
No, snow. Winter's here.
I'm trying to find one of those reds that was just so beautiful. Like, you can see if I start digging over here. But there was a red here somewhere. Oh, here it is.
You found it?
We've got a dead fish. So you tell me when you see how they've dug.
I've been rolling the whole time.
Oh, you've been running? Okay. Well, here we have an example of some pink salmon that have dug a red. Now, the water surface elevation was a lot higher when these salmon were spawning in October. We're in the middle of November right now. And so you can see there's a clean piece of gravel. It's kind of teardrop shaped. And so this is the upstream end of the red. And then there's been a bunch of excavation that's gone on. And then we have here what's known as the tail spill. So the female, and maybe this is her right here, goes along and she digs the gravel by basically flopping her tail, her caudal fin, in an upward direction. The gravel gets lifted off, carried in the current, and then gets piled in this little bit of a pile. And as she digs forward and builds a bit of a hole, the male will come along, they will pair up and they will spawn, and then she'll dig a little bit upstream and that gravel will fall into the hole and cover up the eggs. And she will do this a number of times. And so what you're seeing here is a female that's basically carved out a home for her young, and what she's done is she's laid eggs down in the pits and then covered it up. So hydraulically the water before she digs the gravel is pretty laminar, but after she digs the gravel out and her eggs will be somewhere down in here, And they'll probably be dead because this is pretty high elevation.
Marv?
But hydraulically, it'll be like an airplane foil or an airplane wing, and the water will come through the bottom of the red, and it'll hit this hump, this what's known as the
We got 1.5 minutes.
tail spill, and the water will be driven down through the bottom of the red, and the eggs or embryos will be irrigated with water, and all the waste will be taken away, and they will be well oxygenated. So it's a very sophisticated engineering design that these fish use to make sure that these young ones survive to the next generation.
Well, very good. Good educational stuff there. Thanks, Marvin, for explaining that, and I'm sure the viewers will enjoy that. And we'll go down and see how they're making out on the seining.
Not a problem.